All right, we're back. We're on page 8 of notes 13 of Calc AB. All of these are pretty much review problems, which are like super review. I don't think they really have anything to do with antiderivatives. Maybe. I don't know. We'll find out. But let's see if we can do it. So, holy cow, this is like really calculator. So, find the slope of the line tangent to f inverse, the inverse of f of x equals this crazy thing at x equals 2. Okay, so first thing to remember is that this is on f inverse, right? So f inverse has some sort of ordered pair that's 2 comma something, right? So so this is my thought process. So f inverse has an ordered pair that's 2 comma, let's say a, which means f of x has an ordered pair that's a comma 2. So I can figure out what a is. Well, my calculator can figure out what a is. So I need to figure out what a is. So I need a, right? So what I'm going to do is I'm just going to say if f of x equals 2, the solution to that should be a, right? Because I know the y value is 2. I know the function, sort of, is this monstrosity. So if I set that equal to 2, I can solve for a. So I'm going to do that. This is like super calculator. But it's good because we're going to store some stuff, and I don't know how often you've done that. I'm going to make this bigger. I don't know what impact this has on the video, but we'll see, I guess. Or you'll see. F of x, and then colon equals, which is control, and then the templates, if you don't know that. Natural log of arc. I'm typing arctan. It's easier to just use the trig button for you. I'm typing exp. It's probably easier to use the e to the x key. Plus 1. Okay, so that's f of x. I need to solve this. So I'm going to use solve. Solve f of x equals 2 for x. You might find in some scenarios, maybe in a lot of scenarios, it's actually easier to do this graphically because it's like a little easier to extract the answer and then store it. So I'll do it 2 different ways. So I went up and I pasted down. And what I'm going to do is I'm just going to delete the x equals part. I'm going to say a and then control templates, so a colon equals. So why am I storing this? I'm storing this because I need to use it. I need to sub it into the next thing that I do. And so it's easier if I have it stored. So I actually know that a is approximately, so I'm writing this down, 1.678. So 3 decimals when you handwrite, as many as you can on the calculator. So a right now for me is this many decimals. It's actually probably more than this many decimals. It just doesn't show you them. So now I need to do the derivative of the inverse is 1 over the derivative of the original at the corresponding point. So the derivative of the inverse at 2 is 1 over the derivative of the original at a. So I'm going to find that. I'm going to do 1 over the derivative of f of x such that x equals a, and press enter. So I get 1.315-ish. So let me go, I'm gonna go back to the notes so I can write this and you can like see what I'm doing. And then I'll go back to the calculator to do some other stuff. Okay, so I'm gonna clean up my notation a little bit. I'm gonna say let g of x equal f inverse, right? So g prime of 2 is 1 over f prime of a. And that we've found out by using the calculator is 1.315. 1.315. So now our tangent line. So tangent to g of x at x equals 2 is going to be y minus, so the y coordinate is 1.678. So I think it's really useful to, well, let me finish this because I will definitely forget what I'm doing. And then x minus 2. I think it's a really good idea to write down this ordered pair at some point. just so you like remember what you're doing. Because I see a lot of people use the wrong thing, right? Like you need to know that x is 2. What's the y value that goes with it? It's a. We found a. All of that's good. Okay, I'm gonna just show you really quickly. Well, maybe not really quick. Do I do anything really quickly? I don't know. I should do like a speed run of my notes. I don't know how long it would take me to get through all of them if I had done that. Probably still forever. I'm gonna graph f of x. I'm gonna graph 2. I'm gonna find the intersection, which for me is menu 814. Might be menu 813 for you, depending on the calculator that you have. This, I'm gonna store this as like, I don't know, C. So what I'm doing is I'm arrowing over it, and I'm gonna press Control Menu, and you get like this contextual thing. So I arrow over it, Control Menu, choose Store. I'm gonna store it just as C. And now if you go back to the calculator page, you can type C, and it's stored. Sometimes that's easier to do. Actually, almost always it's easier to do because you have a little more control on the graph page than you do on the calculator page. Like if there were 5 intersection points, on the graph page, you can control more easily like what you're looking at. I think it's easier to store. But it all comes down to like how much you practice. If you don't practice, they're all going to be impossible. So practice. All right, let's see. If we go back, what else we got? How many problems? All right. Was it like should we do? Let's do this one. Given that f prime is quantity x minus 3 squared, natural log quantity x plus 1 times the arctan of quantity x minus 3. This has to be a calculator problem. And f of 2 is equal to 3. Approximate f of 2.1 using line tangent and determine if this is an over or underestimate and justify. All right, we know what we're doing, right? So we are using a calculator, basically. So I'm gonna set this up so that I can just like write some things though. I know that f of 2 is equal to 3. I'm gonna find f prime of 2. I'm sure that that's gonna be a decimal. And so let's start there. So back to the calculator. Calculator is kind of your best friend on like a lot of things. So make sure you know how to use it. So I usually store derivatives as fp, or sometimes I store them as df, like the derivative of f or f prime is kind of like the logic. I'll go with df. df of x colon equals x minus 3 squared natural log. I would not want to take this derivative by hand. Times, you don't actually need multiplication there. Like you don't need the symbol. I think I just did it because I freaked out when I saw the bold A. Okay, so that is the derivative. So df of 2, which actually I guess you could have gotten by hand. I'm gonna use decimal. Is like I didn't realize that was the derivative despite having reading it. What? Despite reading it. 0.863. Okay. So what are we doing here? All right, let's like write, let me write the tangent line here. So it's gonna be y minus 3 equals this slope. So I'm just gonna write df of 2 times the quantity x minus 2. And then such that x equals, so I'm basically finding the approximation at 2.1, such that x is 2.1. Get this, I need to add 3. All right, so 2.914. All right, back to the notes, everybody. And let's write that down. So I gotta write down the tangent line. I've gotta show f of 2.1 is approximately something, then I'll write that down. So the tangent line, tangent to f at x equals 2 is gonna be y minus 3 equals negative 0.863, negative 0.863 quantity x minus 2. Okay, so f of 2.1 is approximately 3 minus 0.863 times 0.1, or 2.1 minus 2, if you prefer. And then the calculator told us that value was 2.914. So this 2.914. So some people get lost in the equals and approximately equals. So f of 2.1 is approximately this, but this is actually equal to this. So that's why like one of them is an approximate and one of them is an equal. If you don't like that, which a lot of people don't, and I think that's fair, you could say f of 2.1 is, like, after you do all the work, just f of 2.1 is approximately 2.914. And it like feels a little better. Okay. Is it an over or an underestimate? Well, how do we tell? Concavity. So let's go back because there's no chance we're doing this by hand. Let's have, I'm gonna have the calculator graph the second derivative. So doc for graph page, the derivative. So since I say df is the derivative of f, I only need to find its first derivative to get the second derivative of f, right? So I'm finding the derivative of f prime. That's f double prime. So this, and then I really need to see it between, I only need to know between 2 and 2.1. Like, is the second derivative positive? Is the second derivative negative? So it's definitely, second derivative is positive on the interval from 2 to 2.1, which means f of x is concave up on that interval, concave up, tangent line is below, definitely getting an overestimate. So let's go back and write that up. So we know that the second derivative is positive. That's what the calculator has told us. So I'm gonna say basically that. So since f double prime is greater than 0 on 2 to 2.1, you could just say like that we're getting an underestimate, but I think it's better to give like a little more information here because, you know, make it clear, right? So f of x is concave up, therefore tangent line gives an underestimate. How much room I can squeeze it in. Underestimate. So I think that's a good answer. You could go, well, I mean, it's good answer, but man, the spacing on this, I'm not going to be able to, oh, I got it somehow. It like, oh, I missed, let's move the decimal, can we? I can't grab it. I'm like, I keep circling this decimal point here. Be gone. Okay. I think that's a good answer. I'm gonna stop this here. I don't know how long the next problem is gonna take, but I feel like this video is already pretty much long enough. So I will stop this, come back in the next one and actually finish these notes. These notes are taking me way longer than I thought they would. So I'm gonna be kind of glad to see them go. But anyway, I'll see you in the next one.